Since time immemorial, the moon has captivated the human imagination. As the Earth's nearest celestial neighbor, it has been a guiding light, a calendar, and a symbol of mystery. Ancient peoples tracked its cycles to govern agriculture, ritual, and navigation. Its pale glow has inspired countless myths, poems, and songs. From the Mesopotamians to the Greeks, from Chinese philosophers to indigenous cultures across the globe, the moon was often revered as a deity or a sacred presence, a silent observer of human history. Yet, beneath this romanticized surface lies a formidable world of extremes. The moon's environment is harsh and unforgiving. Temperatures swing from blistering heat exceeding 120 degrees Celsius in sunlight to bone-chilling cold plunging below minus 170 degrees Celsius in darkness. Its surface is bombarded by cosmic radiation and micrometeorites, with no atmosphere to shield against these dangers. The lunar regolith, fine, abrasive dust, poses its own hazards to equipment and humans alike. For millennia, reaching the moon was the stuff of fantasy and science fiction. It was only with the advent of the space age, a testament to human ingenuity and ambition, that these fantasies were transformed into reality. The Cold War rivalry between the United States and the Soviet Union fueled a technological sprint culminating in the Apollo program. Between 1969 and 1972, 12 astronauts walked on the lunar surface, collecting samples and conducting experiments that revolutionized planetary science. These missions planted the seeds of humanity's future in space. But after Apollo, for decades, the moon was largely left untouched by human feet. Instead, robotic probes ventured to distant planets and interstellar space. The moon's harshness and the immense cost of lunar missions contributed to this shift in focus. Mars, with its tantalizing prospects for past life and potential habitability, became the new goal. Now, in the 21st century, the moon is re-emerging as the focal point of a new space race, one marked by unprecedented complexity. Unlike the binary Cold War contest, today's lunar ambitions are multifaceted, involving numerous nations, commercial enterprises, and international alliances. Central to this unfolding story is the evolving partnership between two historic space powers, China and Russia. China's ascent in space exploration has been nothing short of meteoric. Where once it was considered a latecomer, it now boasts one of the most ambitious and capable space programs worldwide. Its Chang'e series of lunar missions, named after the Chinese moon goddess, have achieved milestones that stunned the global scientific community. The first soft landing on the moon's far side, deploying rovers to explore unexplored terrain, and successfully returning lunar samples to Earth for the first time since the 1970s. These successes signal China's intent to be a dominant force in space exploration, merging scientific curiosity with strategic foresight. Russia's role in space exploration is foundational. It launched the first artificial satellite, Sputnik, and sent the first human, Yuri Gagarin, into orbit. Its early lunar ambitions were formidable, though the Soviet lunar program ultimately fell short of a crewed landing. Decades of economic and political challenges followed, but Russia's space expertise remains formidable. Now, Moscow seeks to rekindle its lunar dreams through cooperation with Beijing, leveraging its extensive experience in crewed spaceflight and propulsion technology. Together, China and Russia have announced plans to build the International Lunar Research Station, ILRS, a permanent outpost on the moon's surface. This collaboration transcends simple joint missions. It aims to establish a sustained human presence, with rotating crews living and working on the lunar surface year-round. The ILRS is envisioned as a modular complex with laboratories, habitats, power systems, and infrastructure to support scientific research and exploration. At the heart of this endeavor lies the promise of lunar resources. Water ice, trapped in permanently shadowed craters near the moon's poles, is a game-changer. Extracting and processing this ice could provide drinking water, breathable oxygen, and rocket propellant, making the moon a refueling station for missions deeper into the solar system. This concept, known as in situ resource utilization, could drastically reduce the costs and logistical complexity of interplanetary travel. Beyond water, the moon's regolith contains valuable materials such as rare earth elements, helium-3, a potential fuel for future fusion reactors, and metals that could support construction and manufacturing in space. Accessing and harnessing these resources could not only advance space exploration, but also transform industries on Earth. However, the ambitions of China and Russia are unfolding against a backdrop of geopolitical complexity. The United States, through NASA's Artemis program, aims to return astronauts to the moon by the mid-2020s and establish a series of bases and orbital platforms, potentially in partnership with international and commercial entities. Europe, India, Japan, South Korea, and emerging private space companies like SpaceX and Blue Origin also have lunar exploration plans. China and Russia's partnership, therefore, signals the emergence of a parallel space power block, challenging the Western-dominated space architecture established over the past half-century. This raises profound questions. Will lunar exploration be a cooperative international effort or the next theater of geopolitical rivalry? How will the global community navigate competition for lunar resources and strategic dominance? Space law adds another layer of complexity. The 1967 Outer Space Treaty, a landmark agreement signed by over 100 countries, prohibits sovereign claims on the moon and other celestial bodies. But the treaty is vague on resource extraction, commercial activities, and permanent settlements. As nations move to establish bases and mine resources, new legal frameworks will be needed to regulate these activities and prevent conflict. The stakes are high. Militarization of space, dual-use technologies, and the placement of strategic assets on the moon could escalate tensions. Simultaneously, opportunities for scientific breakthroughs and international collaboration abound. The decisions made in the coming years will shape the norms and governance of space for generations. Beyond the political and economic dimensions, the moon embodies the enduring human spirit of exploration. Living and working on the moon will test our technology and resilience. Astronauts will confront challenges of radiation exposure, low gravity, and psychological isolation. Developing reliable life support systems, energy sources, and sustainable habitats is essential to making the moon a home away from home. China and Russia's lunar ambitions represent humanity's next giant leap, a venture into sustained extraterrestrial living. Their work will advance our understanding of planetary science, human biology in space, and the technology needed for journeys to Mars and beyond. Yet, this venture also invites reflection. The moon is a mirror reflecting our highest aspirations and deepest divisions. It is a frontier that challenges us to rise above terrestrial conflicts and unite in pursuit of knowledge and survival. How humanity navigates this new chapter of exploration will define not only our future in space, but our identity as a species. The moon is no longer just a distant satellite. It is the stage where the future of human civilization will be forged through science, diplomacy, technology, and vision. China and Russia's actions are but the opening act of this epic drama, a drama in which every nation and every person has a role. As the world watches these two space giants embark on their lunar journey, the question remains: will this new era be one of collaboration and shared progress, or competition and conflict? The answer will determine the fate of not just the moon, but the very future of humanity among the stars.